Hello guys, welcome to Geeks for Geeks. Today we are going to see another problem, how to detect if two integers have opposite signs. The problem statement is, given two signed integers, write a function that returns true if the signs of given integer are different, otherwise false. For instance, if the input is -1 and +100, the output is true because both the numbers are of opposite sign. If the input numbers are -100 and -200, the output is false because both the numbers are of same sign. We are going to use Bitwise Operations to solve the problem using three different methods. Let's see. Before we go ahead, we need to know a very basic fact. All negative numbers have its sign bit set to 1 and all positive numbers have its sign bit set to 0. For any binary number representation, the leftmost significant bit is called most significant bit, and it is also a sign bit. For a negative number, the sign bit is set to 1, and for a positive number, the sign bit is set to 0. And if we perform XOR operation on a negative and a positive number, the resultant number will also be a negative number and its sign bit will be 1. We are going to use this fact to solve this problem. Let the given integer be x and y. The XOR of negative and positive number will result into a negative number and its sign bit will be set to 1. As we saw then, if x is negative, the sign bit is 1. If y is positive, the sign bit is 0. XOR will result into a negative number having sign bit set to 1. The code for the same is, we have a function called opposite signs. It receives two parameters, first number and the second number. In the return statement, we XOR both the numbers and check if it is smaller than 0 or not. If it is smaller than 0, then we return 1, which indicates both the numbers are of opposite signs. If number is not smaller than 0, we return 0, indicating both the numbers are of same sign. The second method is, we can use two comparison operators to check if numbers have opposite sign. The function is opposite signs again receives two parameters, first number and the second number. In the return statement, we have three different expressions. Let's see how it's evaluated. The first expression is if x is smaller than 0. If it is true, that means x is a negative number. And then we check if y is greater than 0, which means y is positive number. If it is also true, we return 1. If y is not greater than 0, we return 0, indicating both the numbers are of the same sign. Now, if x is not smaller than 0, this means that x is a positive number. And then we check if y is a negative number. If y is a negative number, we return true, indicating both the numbers are of opposite sign. If y is not a negative number, we return 0, indicating both the numbers having same sign. Let's see the third method. The third method works only with 32-bit integers. We can use right shift operator to shift the sign bit to the rightmost position and check if it is 0 or 1. This method is quite similar to the first method. Here in the return statement, we XOR x and y, and then we shift the sign bit, which is the leftmost bit, to the rightmost position. And if the sign bit is set to 1, we return 1. If the sign bit is set to 0, we return 0, indicating if the sign bit was 1, the numbers are of different signs. And if the sign bit was 0, numbers are of same sign. Thank you for watching. Please leave us your likes and comments.